Hello, welcome back to another flipped classroom lesson. This one is about collecting data for your flipped out lab. We want to have that lab finished in the next day or two, and having a data chart like this should help. Some of you will be testing the height of the flipped foil, and some of you will track the distance um, across. So that's what this chart is about. Um, this chart's more complicated than a lot of them, so it's a good one to show you. It has the trials here, and it has the angle of the flipper, the plastic container here, 10 degrees, 20 degrees, 30, and 40. I put some sample data in to work with today. Um, let's say you're using the smaller foil ball and you've flipped it 3 different times, and you got 100, 110, and 130. Well, those trials are a good start, but now you have 3 numbers. You can only put one of those numbers on the graph, so you have to average them. Here's how you're going to do that. Add up the 3 trials. Uh, 100 plus 110 plus 130 does equal 340, and if you divide that by the number of trials, you get 113 centimeters. 3 goes into 3 once, 3 goes into 4 once, and 3 goes into 10 3 times. So that's my quick way of showing you how to average. I want you to practice now. Take a minute when the video is paused and average the larger foil ball distance. The distances are 80, 70, and 100. Go ahead and give that a try. Okay, now that you've averaged that, um, you can see how easy that is. Once you have the average, you have a better number to use in your graph. It gives you a more reliable number. Remember that phrase: a reliable number is what you're looking for. After you run all the trials and then are ready to start your bar graph, be sure you have enough room. This is 400 centimeters at the top. You may need more or less to make that the right number. This is the distance that the flipped foil would go. The size of the foil ball for each trial is a small one and a large one, a small one and a large, small and a large, and so on. The angle goes from 10 to 20 to 30 to 40, just like the top of the chart. The bar graph is the right kind of graph for a particular reason. I want you to talk about that with your neighbor right now. Great. As you've discussed, bar graphs are better at comparing 2 absolute numbers. We're not comparing a percentage, that would be a circle graph. We're not comparing change over time, that would be a line graph. The bar graph is the appropriate one here, and you can see on our made up numbers that the smaller foil ball went a little over 100 centimeters, while the larger foil ball didn't go quite 100 centimeters, both for the angle of 10 degrees. So every time you finish a group, you would plot that out, and the graph would be much easier for your audience to understand than the data chart. And that's why this is not the finished product. This will be. I hope you have fun doing the lab. Good luck.